Alright guys, so this is a problem that was sent to me that a student had a question with. Um, it says use calculus to prove that the relative minimum or maximum for any function as shown below occurs at x equals the opposite of b over 2a. Now I don't know if you guys if that caught your attention. That right there should look familiar to you guys. That is what we call our that is the equation for our axis of symmetry. Now, your axis of symmetry is very special in calculus, it's special in algebra. So if I were to sketch out a quadratic, it's not perfect, of course. I'm just sketching it out, like I said. But, right in the middle of that quadratic, you have a line of symmetry. And what is special about that line of symmetry is that on that line of symmetry falls your relative extrema. So if we can find our axis of symmetry, which I will label, um, I'm sorry, if I label as AOS, my axis of symmetry, if you can find your axis of symmetry, then you can find that relative extrema, in this case, which is a minimum, but relative extrema is a max or min, right? By taking the x value, plugging it into the function, and finding your output, which would give you your ordered pair, right? So your axis of symmetry is this vertical line, which allows you to find that, which can help you find that relative extrema. So the question is, where would the relative maximum or minimum of the function occur? Um, okay, so we understand that if you want to find a relative maximum or minimum, think about the steps that we followed in chapter 1, chapter 2, and now in chapter 3. If I want to find those relative maxima or relative minima, then we first have to find those critical points, because at those critical points we understand that something's happening. I just don't know what at the moment. So we got that one right, this particular student. But this second part says determine the derivative of the function for f of x is equal to ax squared plus bx plus c. Well, if my f of x is equal to ax squared plus bx plus c, then to find the derivative, that's going to be, we would bring the 2 out front. That's going to give me 2 times a times x plus b. And that's literally all it was looking for, was the derivative of that function. Um, the last part here, it says determine the critical values of f of x equals ax squared plus bx plus c. A critical value can occur where f prime of x is equal to 0. In other words, where your derivative is equal to 0. So it's telling me what to do right there. And where f prime of x does not exist. So we know this. We've went over this. We've taught this. We've discussed this in class. That to find your critical points, you want to take your derivative and you want to determine where it's equal to 0 and where it does not exist. And it's just reminding you of that. It says if since the derivative is a polynomial, and what it's saying is since this derivative that we found is a polynomial. Polynomials are written in the form of a quadratic, for example, is a polynomial. Linear functions are polynomials. Um, Trinomials. All of those, polynomials. But it says there are no. So what that tells me is that there are no x values where the derivative does not exist. Therefore, I don't have to worry about this part for my critical values, what it's saying. To find the critical value, all I need to do is take the derivative and set it equal to 0. So my derivative here is 2ax plus b is equal to 0. So let's find that critical value. Um, let's see if I can cover up these this stuff at the bottom. Can I change my pen color to white and erase all of this at the bottom? Let's do this. I just want to kind of cover this up so I can write over this. It won't look like a mess, not too much of a mess. Okay, so if I want to solve for x, what I would first do is bring that b to the other side. That leaves me with 2ax is equal to negative b. Okay. Solve for x, what I want to do is get rid of the 2 and the a. If I divide by 2a, the 2a on the left-hand side will reduce, it simplifies, and it just leaves me with x. And on the right-hand side, that leaves me with negative b over 2a. So it says, therefore, the only critical values will be found where? I mean, it's asking me where would the critical values be for this particular equation up here. Well, think about it for a minute. I mean, I have my answer in front of me, and you really had your answer given to you at the top up there. But think about it. If I have a quadratic, this quadratic I have over here in the corner, where is my critical value at? What 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 points do I have where something important is happening there? I have that relative minimum there, that relative minimum, or actually in this case an extreme minimum. My minimum point is on that axis of symmetry. So what we just found is that when I have a quadratic, that critical point is that extrema, that maximum or that minimum, and we just proved how to find that maximum or minimum, or we showed um, that the maximum and or the minimum is going to be located at x equals the opposite of b over 2a.